Hello, Coach Travis here with another calculus video. So this video is about Newton's method for approximating the roots or the x-intercepts of a function. And in particular, this video is showing you how you can use a spreadsheet to really easily perform the Newton's method algorithm. So again, Newton's method is an iterative process. It's you make an initial guess, and in this case we're going to guess -1, and then we have a formula that uses our guess to get a better approximation. And then what you can do is you can then take that better approximation and put it back into the formula to get an even better approximation. So that's what I mean by an iterative process. It's one that you perform the operation, you get an answer, and then you take that new answer, you put it back into the process to get an even better answer. And so this can be kind of tedious to do by hand or with a handheld calculator. But a spreadsheet will make the process very easy. So I really like using spreadsheets to do iterative processes such as Newton's method. So anyway, so the idea is, what's the problem here? We want to use Newton's method to approximate the root of this function in the interval from -2 to -1. And the problem wants us to tell, sort of what's the second approximation, or the second approximation you get from Newton's method. And it tells us the initial guess to use. So x0 is the notation we use to denote the initial guess. So that's going to be, I'm just going to type that in my spreadsheet as -1, and then we'll go from there. So all right, so the idea is, so what I typed in the spreadsheet, this is just x0, this is just a label. I just literally typed x0 into this cell, and this I literally just typed x1 into this cell. So these are just placeholders, and this I literally typed the number 1. All right, so right here in this cell is where the action is going to be. So what I'm going to do in this cell is, whenever you type a formula in a spreadsheet, you want to start with the equal sign. So that's telling the spreadsheet that I'm entering a formula. So I start by entering the equal sign. And now what I'm going to enter into this cell right here is I'm going to enter this formula, because this is the Newton's method algorithm formula. But the catch is, instead of typing in x0, what I'm going to enter is I'm going to enter a cell reference. So you might say, oh, you might think, oh yeah, instead of x0, I'm going to enter -1, because that's what x0 is. And that's true. If I was going to be doing this on a calculator, that's exactly what I'd be doing. But as you'll see, what I'm going to do with the spreadsheet is I'm not going to even enter the number x1. What I'm going to enter is I'm going to enter a cell reference. That is, that this cell right here is in the B column and the second row. So I'm going to enter the cell reference B2. So anyway, you'll see what I mean when I type it in. So all right, so instead of x0, I'm going to type in B2. B2. Oops. B2. Because that's going to refer, the spreadsheet is going to interpret B2 as being whatever number is in the cell B2. So again, everywhere here, I'll highlight it. Everywhere whoops, wrong highlighter. Everywhere I see an x0, I'm going to type B2. So all right, so let's see. So we got a B2. And then the formula says now we have to subtract. So I'm going to subtract, and then in the numerator I have f of x0. Okay, so if you think about, well, let's look up here, what's the formula for f? The formula for f is, it's going to be 3 multiplied by x0. But again, instead of x0, I type in b2. And then I raise that to the third power. and then I add 2 times x0. But again, remember, whenever we say x0, what I'm going to type in instead is b2. And then we minus 4 times b2, and then plus 1. So that, what I got right there is that's this function right here, only instead of x in the formula, I have the cell reference b2. Okay, and we're not done with the formula yet, because then now I have to divide by if I look here at the formula, the Newton's method algorithm formula, I now have to divide by f prime of x0. And so for convenience, I went ahead and found the derivative. The derivative of this is really easy, but I just wrote it down here for easy reference. So the derivative of f is 9x squared plus 4x minus 4. So all right, so I'm going to type that in here. And again, instead of typing x's or x0s, I'm going to type in b2. So it's 9 times b2 squared plus 4 times b2. Oh, wait a minute. Make sure to use a multiplication sign, because if you don't put a multiplication sign, the spreadsheet is going to think that this is like some sort of cell reference or something, and it's going to get confused. So make sure that you put in multiplications where you need to. And then minus 4. And also make sure that you use parentheses appropriately, because if I didn't have parentheses there, I wouldn't be doing the correct division operation. So make sure you use parentheses carefully. All right, so there we go. So I've got it entered, and now I'm just going to press return, and it gives me the answer. So that is it. What it just did was it just did this computation, only everywhere you see an x0, it put in -1. So it did this computation automatically, and it just put in a -1. And what's fun now is I could change this if I wanted to. Like if I change this to a 2, then this formula will automatically update. So the behind the scenes formula is exactly what I typed in, but when I press enter, it evaluates it, and it gets whatever it gets. So this is a fun thing, you know. It's like a magic calculator here. I've got the formula built into the spreadsheet, and no matter whatever number I put here, the formula is automatically going to update. So let's go back to -1, because -1 is what they told us to start with. And here's the really totally cool thing about a spreadsheet is normally what you'd have to do is, if you were working with a handheld calculator, now you'd have to go through this operation all over again, but with a -5 plugged in instead of a -1. But what's really great about a spreadsheet is what I can do now is I can just highlight these two things and then move my mouse to the lower right corner here and left click and drag, and then let go. And what happened here is, what it did was it copied the exact formula from before, only it updated the cell reference. Instead of being B2, notice it's now B3. So like if we go back and if we look at the formula, sorry, I did that fast. If we look at the formula in this cell, the cell with the -5 in the cell B3, if we look at the formula in the cell B3, the formula is referring to this. It's referring to cell B2. So that is, it's using the value up here in B2. But then down here in this formula, with the -3, the formula there is referring to the cell B3. So it's doing the same formula, and I didn't have to type the whole thing in again. It's doing the same formula, only now it's putting the element in the B3 cell, which is the -5, which is what we want. So I hope that made sense. And so now, and you could do this as much. The amazing thing is you can do this as much as you want, and you can get. So you could, if you wanted to do Newton's method a whole bunch of times. Whoops! I keep pressing the wrong button. If you wanted to do Newton's method a whole bunch of times, then this would make it really easy, because you can just. It's just built it. You programmed it into the spreadsheet, and the spreadsheet will do the computations very quickly. And also, just for reference, you can see now how the numbers are kind of stabilizing. So the claim is that this number right here, -1.618, that's going to be very close to the actual x-intercept of this function on this interval. If you draw the graph of this, I think you'll see that this is very close to the x. This is basically the x-intercept right here. Okay, but anyway, the problem only asked us for x2, so for the purposes of our problem, I would enter this is what I would enter into the homework assignment, and then we'd be done.